Can models officially reason now?
They have risk levels for models. I think we're still good, so no terminators inside.
Are agents as a service the new software as a service?
Agents are going to be everywhere, and multi-agents, operating in teams and crews, multi-agent collaboration is going to be huge.
Are LLMs the true unlock for personalization?
And we came up with the notion that an active league is a happy league.
I'm Brian Casey, and I'm joined this week by a world-class panel of experts across engineering, research, and product. And we're excited to get into this week's news in AI. This week, we have Natalie Baracaldo, Senior Research Scientist, Master Inventor, Aaron Botman, IBM Fellow, Master Inventor, and Chris Hay, Distinguished Engineer, CTO, Customer Transformation. All right. So, as every week, we start out with a quick hot take question. And this week's question is, was O1 Preview worth the hype? We'll start with you, Chris.
I live for the hype, and I wait for the next model. Where's my new model?
It's been a week already, so it makes sense. Aaron, what about you?
I think scientifically, this whole chain of thought allowing systems to teach itself is very interesting. But I need to wait and see how it works out in the implementation details in the application space.
And Natalie?
I think the new model is really interesting from the security perspective. Some of the metrics that they show really demonstrate improvement. So I'm very excited about it.
All right. Well, let's jump right into it. And actually, that's going to be our first topic this week. So it was funny. So this model released last Thursday, actually. And as a little inside baseball for our listeners on this show, we actually record this show on Thursdays every week. And then we go into production and we release the show Friday morning. This 1 week, we didn't do that. We actually recorded the show on Wednesday. And then, of course, the model came out on Thursday. So that's just the way of the world. But this was an announcement that has been hyped for a long time. For anybody who's on Twitter or X, you've seen the memes around Strawberry for what feels like an eternity at this point. And then it's finally here. It happened. The model arrived, and it wasn't just released as a blog post. It was actually rolled out to the broad user base within ChatGPT, and I think some of the API as well. And the interesting thing about this model is that it introduced chain of thought and reinforcement learning techniques into the model itself. So not as a way to interact with the model, but as a way that is an embedded capability inside of the model, which is definitely kind of a new approach there. And we've seen pretty important and noteworthy improvements in reasoning capability as a result from that. And so maybe just because you touched on this specifically in your first answer, I actually just want to start with the interesting kind of science around including chain of thought and reinforcement learning techniques within the model itself, and just like get your reaction to that and why it's important, the things that are exciting to you about it. And maybe, you raised a couple questions even in your initial answer, but like some of the things that you're still waiting to see.
Yeah, I think it's really fascinating how, chain of thought was really introduced in 2022, and it's just accelerated and it expanded to become this self-education for large language models by 2023. And here we are today with Strawberry. So it's great how fast technology is moving. And what I really like about this is that these chain of thoughts, it helps us to introspect the mind of a generative AI system. And what happens is that you might seed a system with problems and answers so that you know whether the chain of thought helped to induce the right answer. And then later, you can keep iterating over and over and over with these chains of thoughts with newer variations of the problem, so it learns new skills over time. And you create variations of these problems, and you have almost like a panel of these generative AIs answering with different strategies. And if all of the answers align towards the same answer, even though you don't have a ground truth, then more than likely the chain of thought is working because it's converging towards a less variant type answer. And through all of this looping, we have these gradient updates so that it can learn more and more. So we have gradient updating and we have end context learning put together. But the last thing I'll mention is that what I really liked is how they broke out reinforcement learning as what they call train time compute. And then they have this thinking time as test time compute. So the thinking time is kind of when it iterates and it's passing these many chains of thoughts, along, and then the training time is where it's doing this in context learning and perhaps doing, some, fine tuning in there.
That's great. And Chris, I know you in particular have been, I've been following this on Twitter as well. So, I'll maybe give you some space to have like a more open-ended kind of reaction to just the release of this, and the extent to which like it was and wasn't what you were expecting it to be. But would love to just get your thoughts.
I thought it was super interesting. I mean, just to sort of go on sort of some of Aaron's points there, the reinforcement learning part is really interesting. So if you think of the chain of thoughts for a second, then if you're solving something like a puzzle, so maybe you want to get it to solve a Sudoku grid, or maybe you want it to calculate, which book, if Phileas Fogg was listening to the Harry Potter books, and what book would he be on by the time he got to India, right? If you think of those sort of questions, then the answer isn't actually the important part. Of course, you want an accurate answer. The big thing you really want to do is reason in the correct way. And the sort of things that you want the model to be able to do is sort of calculate the distance to India, for example, calculate the sleep time of Phileas Fogg, how long the Harry Potter books are, and then be able to sort of validate those steps all the way across. And that would be similar for something like validating a Sudoku puzzle, right? You want to check the horizontals, the verticals, the sub-mini grids, etc., check each individual number and then see if there's any duplications. That logic is more important than just trying to predict what your next token is. So if you think of reinforcement learning there, the reward model that you could have there on training time can be a lot more accurate, right? You can give higher rewards for each step that it calculates and then how it gets it right. And that means that you can actually train the model towards doing the right type of chain of thought over time. So I actually think that is the proper innovation there. The other thing that I see there is this shift to inference time. And I really like that. It takes sort of 32 seconds or whatever. I suspect that there is some sort of tree search going on there. I suspect they're generating multiple chains of thought. I suspect that as you go down each node of the tree, you're then probably iterating that further to get to some of these answers, hence why the thinking time will increase. And then Aaron says that's going to feed back into the training model later. But I think it's super exciting because it's that push towards inference and being able to scale out there. Now, you could argue that we have that already with agents. But in order for that to work well with agents, you need to back that up with the reinforcement learning. You need to feed that training data back into the model, because if the model can't generate good chain of thought, then you're not going to do very well in your agentic approach. So for me, I find it highly satisfying.
All right. And Natalie, just to bring you in here a little bit, like you mentioned some of the safety aspects, that was definitely a thing they highlighted as well. Like maybe as a way of, I have a couple questions on that, but maybe as a starting point, I'd love to hear your take on like the extent to which you think that capabilities, alignment, and safety are like becoming the same problem space. It's like, can we just make this model do what we want it to do, and you solve all sorts of questions there, or do you can like look at them as kind of more distinct domains?
That's a great question. I think one aspect that really improves with this model is that before in AI, we had the issue of having models that are black box. Black box meaning and we tried in the community to really inspect them, introspect them, try to check the activations, see how they react to different inputs and stuff like that. But this model allows us to have something slightly different, and it's that ability to introspect how it came back with a decision, with an answer. So from that perspective, and to answer your question, I think there may be in some questions and answers a lot of things that get touched upon, and we only have one single model. So probably what's happening is that we're going to be mixing all these things together. The training data contains a lot of different aspects of safety. I think it's important to cover all of them as much as possible. But overall, the main aspect that makes this model so unique from my perspective is that ability to really introspect without having to look into activations and other things that we humans are not super great at interpreting. So that is part of the, I think, exciting aspects from security perspective. The other interesting perspective that I thought it was really interesting is that when we measure safety, we oftentimes have different perspectives, as you were alluding to. So we measure things like jailbreaking attacks, hallucinations. We verify that the model is not going to insult anyone, fairness, all sorts of things. So if we see some of these aspects, for example, jailbreaking attacks, that was one of the metrics that got improved. Maybe I'm talking too much, but I would say that I was really, really impressed with the fact that the community is trying to really incorporate more and more cutting edge benchmarks to try to understand how the model behaves. Because one thing that happens with benchmarks in this space is that they arrive today, people kind of overfit to them. And the jailbreaking attacks will happen the same, and things and all other benchmarks are also kind of having that issue that people really overfit to them. So I was really impressed and continue to be impressed with the security community, the AI security community, try to push the boundaries, have more red teaming, have more interesting stuff, things to throw at these models to test it out. So overall, I'm very hopeful from the security perspective with this model, and it opens lots and lots of opportunities for us.
I have a question for Natalie. So when I read the paper on this, they said that in the testing of the model, they were playing a capture the flag scenario with the model, and the goal the model had was to capture the flag like a security thing. But then the container was down. So the model broke out of the host and then restarted the container so it could capture the flag, right? Very goal oriented. So I'm just like your take on that, Natalie, from a kind of security perspective.
Yeah, this starts to looking like Terminator sort of thing. Is that where you're going? I think it's impressive, first of all, the way the model is trying to find out its way around to solve the issues. Sometimes it's going to do stuff like that it's not necessarily the solution, a feasible solution. But overall, I think the risk level, they have risk levels for models. I think we're still good. So no Terminators inside. We're good from the security perspective. Does that answer? And also curious to know what Aaron has to say about that, because it's such an interesting question.
I mean, yeah, these are really great questions and open-ended discussions. And one of the areas that I found interesting would be these error avalanches, because during this chain of thought reasoning, you're always pushing forward the chain of thought. And if at step 0 you have an error, then that error could populate all the way to step n or n+1, and it just creates this cascade of problems that could happen that might be harder to uncover than a hallucination, because you have these large outputs of chains of thoughts, if you can even see them, because I know Strawberry, in this case, has hidden them from us. They made that deliberate choice, but I know that there are some work in academia, potentially industry now, about looking at consistency, right? Can these models consistently get answers correct? And that's one way, but I'm looking forward to seeing how Strawberry really handles that. And as more and more people use it, how big of a problem is this this cascading error, or this avalanche of errors that could happen along their reasoning.
And Aaron, I think that's a really relevant point if you have a single chain of thought that you're iterating down, but I'm not convinced that that is the case. I could be totally wrong. We're just guessing. We're just sort of trying to look at it from the outside. But I really feel there's multiple chains of thought that's being generated there, and they're doing some sort of search on that to be able to aggregate it. So if they are doing that, and I think they are, could be wrong, then there might be less chance of that over time, because at least it's got other options to take down that path and aggregate it a little bit. But even then, with the reinforcement learning to the point, then hopefully during training, a lot of that would be taken away because, the reward model will be sort of pushing it in the right direction over time. But yeah, but it's a really great take.
Yeah, one other point I wanted to make too is that just the thinking time, the inference, I noticed that it took 10 hours, that they gave it 10 hours to solve like 6 algorithmic problems. And, that's a lot of time. Right. And so I think I'm also curious to learn as, we get our hands, how much time, what's the trade-off, time versus speed, of response, and learn more about that as well. So I'm just really excited about, Strawberry.
I think that point on the length of time it takes for some of these answers to me draws this like interesting scenario where kind of like the LLM router patterns are going to become even more pronounced, where it's like you're going to want small, fast models that are cheap and low latency to do certain types of tasks. And then when you have to, offloading them to these bigger, longer, more expensive sort of scenarios. The last question I have on this, because I want to have one more question that's kind of like a more existential question that I would love to get the panel's take on this topic, which is on many of these benchmarks, it's now exceeding PhD level intelligence. And not to out myself here, I consider myself a reasonably economically productive person in society, but I do not have PhD level intelligence on all of these tasks. And one of the really interesting reactions from some of the folks I saw on Twitter who are actually like Rune, who's at OpenAI, who works in the lab, came out afterwards and was talking about how he didn't even think product was that important, and that the only game was getting to self-reinforcing and self-improving artificial superintelligence. And the question I have is are people just when do we expect, how capable do these models have to be before we actually see the transformative economic impact?
Yeah, so I think one of the aspects is what's the application and how much you can trust the model to make sure that you don't have hallucinations in aspects that are important. So I think to have real economic impact, we need use cases first that where we can fail, basically. We can fail and we're safe failing and still increase the productivity of people. So that's my take on this. And so, for example, agentic, it's going to be one of those use cases where, for example, you have multiple smaller models and you can try to orchestrate. Perhaps this very big model would help us really orchestrating or try to devise plans when they are difficult. But I think overall, the question of just get a big model that can do everything just by itself, that's probably not going to break all the problems in the industry. I think we need a bunch of smaller models and the agentic approach, and perhaps have another top layer in there to really understand the big context. But yeah, that's how I see things. So I really think industry-wise, things are going agentic. So smaller models working together.
We talk about agents every week on this show. The theme, the show is just we should just call it the agent show at this point. But let's talk a little bit about Salesforce and Agentforce. The thing that is almost most notable about this company is that, I don't want to say maybe they invented, but they popularized SaaS, right? They were the OGs of SaaS. And what happened over the last 15, 20 years is that basically all of traditional software, somebody came along and disrupted each and every single one of those categories with a SaaS version of whatever that product was, right? And that happened in basically every category across the industry. There was this piece written by A16Z that was talking about the death of the Salesforce, not the death of Salesforce, of the Salesforce, and talking about more agentic approaches to this particular space. And they did not believe, actually, that the incumbents had an advantage. They thought the entire space would be so radically transformed by these capabilities that it would be disrupted by new entrants into the market, essentially. And I think that sort of dynamic is what's driving and propelling Salesforce to do and a lot of the things that it's been doing, and the things that I announced this week even. But maybe as a question, as a starting point, and maybe I'll flip it over to you, Chris, is do you think what played out in SaaS is going to play out with like AI and agents too? Like, is every category going to get threatened or disrupted by like an AI native version of that particular space? Like, is that where we're going? And is Salesforce trying to again be the first one to do this?
Absolutely. Next question. No, I'm joking.
We got to fill 10 minutes, man.
So I think I love what Salesforce is doing there, right? So I think the Agentforce thing is absolutely spot on, right? Because they're effectively speeding up the productivity, right? So it's no different from kind of deterministic automation that you would do on these platforms today. And now you're getting the agents to perform that. So anybody can compose an agent that performs a task and do it really quickly. Agents are going to be everywhere, and multi-agents, operating in teams and crews, multi-agent collaboration is going to be huge. And I did a video on this about a year and a half ago, and I think this is true. I think we're heading towards a world of agent marketplaces. So you're going to go in and you're going to have an agent that's good at translation into a native language. You're going to have an agent that is going to be good at performing a particular task, an agent that can do benefit calculations. Every single task that you can imagine, there will be an agent at some point that can perform that task. So therefore, if you think about what Salesforce has done there in their world, what they've created is an agent marketplace for within their SaaS platform. That is cool, right? Anybody can go and compose those agents and bring that together and sort of, solve these tasks really quickly. But that's not going to be limited to Salesforce, and it's not going to be limited to individual organizations. That's going to come out into the real world. In the same way as we have platforms like Fiverr, we're going to have and then people will be able to go and buy those tasks from those agents, and it's going to be a rush, right? And who are the companies that are going to be truly at the forefront? It's going to be people who have the better data, who have the faster agents, the cheaper agents, and they're going to sort of dominate that. So I actually think that the big tech companies are going to enter into that space, Salesforce being one of them. But I see this as a world marketplace. I don't see this being a company thing.
And maybe as like building on that a little bit, which the data point is particularly interesting, where some of the discussion I actually saw that was in the original post from A16Z was actually talking about how they thought even some of the incumbents only had actually a slice of the data that was going to be relevant in the future, because people are treating it like they have all that data. But their belief that in like some of these customer service and experience domains, that like multimodal data that is not and even unstructured data, things that are not necessarily the core of how these things are powered today, will become the core of how they were powered today. So the data advantage is there, but it's not as pronounced as people thought it was. This is one hypothesis, at least. But like Aaron or Natalie, I'm curious the extent to which you think that some of these other data sources are going to represent both opportunities for like new entrants in these categories, or things that are just like some of the existing providers are going to have no problem just like adding a new data set into their existing platforms.
Yeah, I always take a step back and I ask myself, what is an agent? And to me, an agent is a process I can perform a task that could otherwise be done by a human or even another agent. And then this gets to meta agents, where an agent can create yet another agent, right? And there's a couple of paradigms, and the two I'll stick with is sort of, gives you a continuum in between. But the first one is environmental centric agents. But these are agents that reason and think and plan after each action. So they think, act, and observe, right? And then the other one would be a human-centric, where they reason without observations, where they plan up front and they don't really need output from tools in order to take action. And then there's anything in between, right? There's poles, and it seems like that the data aspect, it depends on the use case of which the environment or of which the agent is going to operate within a given environment, right? Is it more of a reactive kind of agent based on a signal that comes from a device, where you don't really necessarily need a lot of external data to create a reaction? Or is it more of a rich textual piece of which it needs to generate new information and provide it back to a human or even to another agent, right? Which could be, instead of human-centric, maybe we say it's agent/human-centric, right? But it's really neat where all this is going. And I do think that, there's different approaches of RAG, that we all know about, where you can augment data pieces into context such that it influences and informs what might output. But this might foreshadow another topic we're going to, but I really like the machine unlearning, right? Where you can maybe unlearn or erase from memory, whether it's this hippocampus type memory or it's embedded in weights from all of these generative AI pieces, but it kind of helps to focus in an agent on what they're meant and supposed to do around their objectives. So they're sort of their SMEs within a particular domain. So rather than being so broad and having this huge large language model that's been trained and it has this inherent data baked into it, you have these very narrow, smaller SME agents, right, that are used that might be fine-tuned in different ways. Maybe you're removing data that's already there, that's been shared by these models that are open source. Or you adding data through RAG or fine-tuning through RAG with your own data that you might have. So there's lots of permutations there. And for Salesforce, I'm really excited that they're partnering with us, IBM, to advance their product to make it more open and trusted, and to help think about these kinds of new architectures and agents and how we're going to be using data and plug and play pieces like Chris mentioned before.
Natalie, maybe a question for you too, which is, I think it was Chris that maybe you made this comment about agents versus like more deterministic workflows, and kind of that evolution over time. One of the things that I've seen a little bit, at least with some of the things that we've been doing, is we've started with a lot of, or using kind of productionizing a lot of like more internal use cases around this stuff that are like big improvements in productivity, things like that. The interesting thing with Salesforce is some of the scenarios that they're talking about are all customer facing things, which is, that like changes the calculus from a risk perspective, from a security perspective. And I'm curious, Natalie, how you think, how are maybe going to approach the balance of, kind of more deterministic workflows versus these more agentic ones?
That is a great question. My perspective is the following. First, we need humans to know that they are still important in this whole pipeline. Because a lot of times when there are mistakes, an expert would very much realize that there's something weird and there's something that doesn't quite feel right. So I think first understanding the human and educating the human, like, hey, this is a tool, but just know that you are potentially smarter than the tool. That's our first step. The second step is actually understanding when we want to explore solutions and when we want to explore the space versus when we want something deterministic, for example, to retrieve a document that is really relevant for certain types of questions. Then we can have a sort of pipeline that it's not as stochastic and that we know we want it that way. So kind of setting up paths within our spectrum of solutions so that when there's something really critical, RAG and other types of technologies can be applied so that we don't hallucinate widely. I think that's part of it. So how do we set it up to make it trustworthy? I think that's the main aspect of it all. And it's going to be a combination of human plus a lot of techniques. I think RAG, just the way it is done right now, may have some gaps. But I think as a community, are moving forward towards solutions where we can specify a little bit better where we are going for each of the questions, for each of the suggestions. But overall, just to mention, I think it's really, really important and really a tool for people to use and leverage in their business cases, especially Salesforce and so forth. So.
keeping on the theme of putting this stuff in production and in front of actual customers, I will move us on to our third segment today, which is talking about fantasy football a little bit and some of the work that IBM is doing in this space. Some of the work that I think this type of work is reaching like huge consumer audiences, and so it actually is. I think some of the more exciting work that we're doing. But Aaron, I want to say the partnership has been going on for like 8 years at this point. But maybe just talk a little bit about the work that we do around partnering with ESPN around fantasy football. And then, like, I know we introduced some new capabilities this year that are driven by LLM. So maybe just talk a little bit about like the partnership there, and then just like some of the stuff that we've brought new for this season.
Sure. Yeah. I mean, perfect. It's been around our project has been around for 8 years, and we actually went down to the labs down in Austin with ESPN, I'd say 10 years ago. And we were trying to figure out what could we do, right, to help fantasy football managers. That hasn't been done before. And we came up with the notion that an active league is a happy league, right? And what we wanted to do was to create this immersive and understandable experience for ESPN fantasy football team managers. And we've grown, right? So now through our 8th year, we have 12 million users that are registered. We're actually live right now, and we're 2.5 weeks into this very long season. And so far, we've had 919 million page views, and we've delivered 4.6 billion insights. Right, so it's really, really heavy, and we are consumer facing. So we have about 5,000 requests per second that we sustain, and one stat that I just looked at this morning, I was just curious, but the most time on a singular player has been 100 days, just in 2.5 weeks, and that player was Justin Fields. Right, so I mean that gives you the volume, right, and the amount of users that we had. And the program, it starts in August and it runs into January of the following year. And what we do is we provide boom, bust, score spreads, and different stats about players to help folks make decisions. And the idea at the beginning, which was novel, is that we wanted to create these different predictions and player states, like do they have a hidden injury, just from text and from videos and sound, not from stats. Right, and that was a hypothesis, and we went through this empirical metrics-driven approach to measure how well we would do, and it came out that we did very well, and we're 8 years into it. And then what we also do is we give trade analysis grades. So if you and I were going to trade, I look at your situation, your roster, your rules, and I give you a grade. And then we also look at waiver wire players and give a grade, and we do opposing team rosters to say how will this player help my team, because there's always some sort of opportunity cost. But the system, it uses a combination of generative AI, classical machine learning, simulated quantum machine learning, and different analytics that's been built up over the years. So it's fascinating. It's very rewarding, to see people use this and to see all of our insights, generative insights as well, on ESPN, on broadcast TV, and on the radio.
I think one of the things that struck me the most was, correct me if I'm wrong, but I want to say that we're using like some of the trade like gets a grade, right? And then we actually use the IBM Granite models as a way of producing some custom analysis associated with the grade. And so that text becomes like personalized, really, in a way, to like not just the person, but actually to the specific situation. One of the things, so I do a lot of work in like media content and the web, and like personalization, I think for every company that works and thinks about their customer experience, like personalization is like the holy grail that everyone wants to get to. And one of the things that is so interesting is that, like, from a content perspective in particular, personalization is just insanely expensive. And it's one of the gating aspects in order to do it. Because like how many, I'm struggling to make one good version of this thing. And now you want me to create like 100 good versions of this thing. It's like never going to happen. And then, so one of the first things I thought about when like generative AI arrived, it was like, I wonder if this is the unlock to personalization. Like, is this the thing that is really going to do that? And so maybe like throw it over to you, Chris, and just like, how big of an impact do you think that like Gen AI is going to have in personalization over time? And like, what barriers do you think exist to like us doing even more of this?
So we're already doing that. So personalizing using generative AI to the consumer, that is something we already do, and we do this with the customer data platforms. So if you think of in marketing, you have the customer data platform where you have the 360 view of the customer. So you have all your clicks, their preferences, all of that kind of marketing data that's all in one profile. Well, if you think about what generative AI is really good at, it's really good at role playing, right? And you'll have seen that before: talk like a pirate, talk like Snoop Dogg, etc. Well, actually, everything that you need to personalize there is sitting in your customer data platform. So actually just getting all of that data that you've got today and then starting to put that in works really well. And we've already been using that to build marketing segments, to then have even finer grained marketing segments than you have today, and then be able to have that personalized content. And of course, that is making it smaller and smaller. That's kind of what's happening today in a practical level, but that's going to come down to the one. And if you think about this, it's not also about generation of content, it's also about verification of content. So let's say you're going to do a marketing message and then you go and do an A/B test, right? That's quite an expensive test. You're doing that against real people and you're finding out, hey, is this work out? But remember what I said, the generative AI is really good at role playing. So you can start to ask the question and say, how likely are you to respond to this content, right? Is this content fitting in your particular persona? So you can start ask questions of that persona that you've got there and understand if it's a good fit, and then maybe start to deal with that a little bit in advance. So generation is absolutely where people want to go for personalization, but actually verification is a really interesting use case. And as I said, we're already doing this.
Yeah. I wanted to just mention too, just to build off of that, some of our challenges within the sports entertainment live events is scale, right? Because I mentioned we have 12 million users that could hit us in a single day, 5,000 requests per second. So we don't enable, we shield our origin servers, right, from all that traffic. And what we do is we invented a way such that we could create batch jobs that would create all these different generative, almost fill in the blank sentences. And then we would, on the edge, we would then look up, what league you're in, because there's an infinite number of scoring rules, right? That makes these personalized sentences different, right? That could, again, be infinite. And so what we do is we meet in the middle and we pull in those fill in the blank sentences on the edge, and then we personalize it, through fill in the blank adjectives based on percentiles of the values of which your players have, right? And then the language that you would expect. So it's almost like theory of the mind, where we want to have our algorithms understand you, your data, your situation, and then personalize the already generative AI and then field it off to you, right? And that's how we typically handle these massively large-scale systems that hit us. And it's quite fun, right, to see the reaction of users when they see the data meeting their expectations and showing them something that they didn't really know. They're like, wow, okay, now I get it. And it shows the power of what we do here for lots of our customers.
Natalie, I know you've actually been doing a lot of work in the space of like machine unlearning. And so maybe just like to throw it over to you and just like talk a little bit about like what this is, why it's important. And just I'll throw it over to you there.
Yeah, thank you. So this is a topic that I think it's very important, very relevant, especially right now that we have huge models. And is that basically, let's revisit for a second the pipeline. We have lots of training data, like a lot from the internet, so untrusted training data, most of it. Then we train a model that's huge. It takes months to do this and a lot of know-how. Then we get the model. And then after that, we start red teaming and we start using the model and we go like, oh, we messed up. perhaps we should have removed or not used certain types of data that we use during these 4 months of training period, for example. So the idea of unlearning is rather than retraining and try to solve the issues by retraining or fine-tuning, what we do is take the model, kind of perform some surgery to it, and so that the effects of data that we don't want are no longer there. There are different reasons for which we may want to do that. One of them is, for example, it turns out that all of the sudden we have this subpopulation of people, and then a lot of the replies that we are getting for that subpopulation of people are not great. So very toxic behavior, for example, from the model. Can we actually remove that a posteriori after training? All the things that we don't like from toxicity. What if somebody, another use case number 2 is poisoning. What if somebody actually took that untrusted set, manipulated the training data in a way that was not great, and then we are starting to understand that that has happened, the model is there, what do we do? Then what we do is try to modify the models to remove that poison information. There is also a use case from, for example, removing copyrighted material. Licenses sometimes are not, even if, for example, we filter, and at IBM, we really make a huge effort to filter copyrighted material when we train. But licenses are sometimes non-static. So one thing that today seems okay to use later on may have changed. What do we do? Do we go back to retraining? Probably not. It will take forever. But if we use techniques like unlearning that modify the model to remove that copyrighted information, that it's going to give us a big advantage. Anything basically hallucinations, that's another aspect of it. What if we determine that the model always hallucinates in certain way? Can we go inspect it, modify it so that we no longer have this hallucination? So the way I would say I like to think about it is that you have a model, it's a patient, and you see that there's something like a virus going on in there. There's this new way to basically give it antibiotics, patch it, and then you have a new model. So we are operating really in modifying the model. And that adds like this extra layer of security to the whole pipeline and helps us also manage the life cycle of the model itself, so that we can basically, in retrospective, every time we find something it's odd or that we don't want, we can go ahead and change that model accordingly.
It's a fascinating thing because so much of the discussion around how we work with models has been about how do we add more data into the model, whether we're talking about RAG or fine tuning. Like these are like, okay, we have a generic model, but we need to get an enterprise data set into the thing so it can operate on our data, on our tasks. Machine unlearning is like the opposite of that, of like, how do we actually get things out of the model? And so, maybe Chris or Aaron, I'd be curious if you think that like, is this domain like going to be entirely like the world of model providers and like maybe some stuff in the open source world, or like do we think that there is a world where like enterprises and when they're thinking like that this type of practices like and techniques around removing data from models becomes like as commonplace as adding data to models around things like RAG and fine tuning?
Yeah, I think it's going to be pretty commonplace, if I'm honest about it. Because if I think about the fine-tuning today, I think fine-tuning is really quite an imprecise art at the moment, if I'm truly honest about it. We do things like freeze the layers, we make it smaller. But if we look at the kind of the space that you've got in the models there, you're just sort of, it's almost like you're just lobbing off stuff and then putting new stuff on top, right? And it's imprecise. So I think as you train models, I think you're going to want to be more surgical, right? And I keep thinking of the episode we did with the Golden Gate Bridge, right? And the work that Anthropic did there, right? Where they were saying that this activation here would happen when you did this, and then we could up it and we could down it or whatever, right? And, you could make it talk more about the Golden Gate Bridge or less or whatever. I think it's going to be in this direction. So you'll have things like unlearning, so being able to remove things from the model, but then I think you're going to want to fine tune in a more precise way. And I think we're all going to become LLM surgeons. I think that's going to become a more precise art than it is today. So yes, and that means the tools are going to get better. How we visualize the models and look at it and be able to do scans and say, okay, this is the point where, you know, it's talking about Harry Potter. This is where it's talking about copyright information. I think we're just going to have a deeper and richer view of the models in time, and we just don't have that today. It's an imprecise art.
It's funny that you mentioned some of the mechanistic interpretability, because like when we were actually having the conversation earlier about chain of thought, I was also thinking about that as like a different way to understand the way the model is thinking, because like there's this whole thing of like we have no idea the way these things work, but like between the interpretability space, between everything around chain of thought, between, you know, machine unlearning, you're having all these sort of different techniques that are all around trying to get at the same problem of like, how is this thing doing what it's doing? And can we, now that we know that, can we make it do something else?
Yeah, I mean, this is almost like watching the movie The Matrix, right? Where, you know, the scene is, do you want to take the red pill, you know, and really learn and understand something that might make you uncomfortable, or take the blue pill and just maintain status quo? And to me, this machine unlearning is almost taking the red pill, where you're getting these models to focus on the data that matters for that particular point in time. And maybe it's uncomfortable, you know, doing that, and just trying to figure out exactly what data does matter and what data doesn't, which is almost like a governance kind of, problem there. And what I really find interesting, I guess getting a little nerdy, is how it works. You know, it's just really, really neat, about how, if you're at a large language model, how you're basically teaching a generic model to predict the next token as if it doesn't have that data, and you construct like a new training set, and then you use that to feed back into the model to relearn as though it never had the data, and it somewhat erases, the weights, on those gradients within the activation function, right? And that's neat. And then when you get to multimedia, right, like image to image, it's great because you can actually have these models forget, how to put in these new objects within images that could be copyrighted, or maybe you don't want to have certain types of objects, or maybe you do want to have certain objects. So you can sort of balance forgetting and remembering, but it's where you can have like these loss functions that span forgetting and remembering, and you optimize both at the same time with two separate models, and you're teaching one of them, what data is the most important. So I mean, going back to the Matrix, I think all of these LLMs and us being surgeons, I think we're going to be taking more of these red pills.
I guess Mixture of Experts is now the Red Pill Pod at this point. So I think that's a good way to end today. So Aaron, Chris, Natalie, thank you for joining us today. Another exciting week in AI. We will be back next week talking about all the news going on. But for all of you out there in Radio Land, you can find us on podcast networks everywhere. Thank you for joining in today, and we will see you back next week. So thanks very much, everyone.